Welcome, elementary educators. In this screencast, we take a look at tessellations. Now, when we talk about a tessellation, what we mean is that we are filling in the plane with repetitions of the same shape, or in some cases, shapes. We are filling the plane with repetitions of congruent figures. No overlap, no gaps, just one shape over and over and over again, filling the entire plane. And remember that a plane is infinite in two directions. So what does that mean? Well, it means that you have some shape. Maybe you have this shape. And this shape, we're going to put this shape on infinite cloner. And that's going to mean that we can take this shape and we can put it next to each other, next to itself like this. And in so doing, we can fill the plane, no gaps, no overlap. We can just fill the plane. We can take this shape, oh, really? This shape over and over again. If we just keep putting it next to itself, on top of itself, we will fill the plane. That's what a tessellation does. It extends in this direction, in this direction, in this direction, in all of the directions. It's just that shape as far as the eye can see in all directions. So maybe you have some shape that is maybe this shape. Can this shape tessellate the plane? Well, sure. Of course this shape can tessellate the plane because we can stack this shape next to each other, right? Like so. And then we can stack this row on top of itself and below itself. And we go out this way and down this way and out this way and up that way. And we can tessellate the plane. Well, can every shape tessellate the plane? Can this shape tessellate the plane? If we put it on infinite cloner, can we tessellate the plane? Well, no. Why? Because there's nothing to fill in that gap. There is nothing that fills in that gap. Even if we turn this shape around, it doesn't fill in that space. There's always this weird gap in here. We can't fill in all the spaces, and tessellations require us to have no overlaps, no gaps. So not all shapes can tessellate the plane, but lots of shapes can tessellate the plane. What about this shape? Can this shape tessellate the plane? Well, what if we tried to line things up like so? What's going to fill in the gap? What's going to fill in that gap? Well, we would take another triangle and turn it around, and it fills in the space. So in so doing, we could tessellate the plane. We could make this work. Well, then does every shape tessellate the plane? What about a pentagon? Does a pentagon tessellate the plane? I can do that better than regular. Let's get a regular one. This is a regular pentagon. Will that tessellate the plane? Well, we can move this over like so, and then I think you know where the trouble lies. The trouble lies in not knowing what to do with this gap here. Like, I can't turn this in such a way that it fills the gap, because if I can explain, and I think I can, we know what this angle is and what this angle is. This is 108, this is 108, which leaves 216 from 360. That leaves 144 degrees for up here and down there. So like we can put another 108 here if we turn this just so, but that leaves a gap. That leaves a 36-degree gap. And who is going to fill that? There's no way to make a 36-degree angle here that fills that gap. And so pentagons do not tessellate the plane, but hexagons do. That's a regular hexagon. That's a regular hexagon. And we can line up hexagons. And then here's this gap. Well, is that going to work? That's not going to work as is, right? Because here's 120 degrees and here's 120 degrees. Those are both 60s, so that's not very helpful. But if we took this hexagon rather, and went like so with it, then this is 120 degrees and this is 120 degrees, leaving a 120 degree gap. But a 120 degree gap can be filled like so. And then hexagons can tessellate the plane. In fact, a hexagon is the shape with the biggest number of sides for which this sort of thing will happen. Triangles, you can do it. Rectangles, you can do it. Quadrilaterals, generally, you can do it. Hexagons, you can do it, but not a shape that's bigger than a hexagon, because you always have the gap problem once you get bigger than 120 degrees. So if you want to make your own shape that tessellates the plane, but you don't want it to be normal, you can take a normal shape and then mess with one side of it, right? So you can make the left side of your shape some jagged little thing here, right? Like you could do that. And as long as you also do that on this side, your figure will tessellate the plane. Here. This shape will tessellate the plane. Why? Because look what happens when you bring this over. The jagged edge that you created over here fits snugly into the place you created over here, because you did it with a translation. And translations on top of translations will tessellate the plane, just like so. You could decide that you want to have a top and a bottom, and then you could decide that you want some shape here going to the midpoint, and then you want to rotate that thing around. So let's rotate that thing around. Rotate that thing around. That's the midpoint. Now you've got a top and a bottom, and you've got a rotation here. So now we'll make sure that that appears on both sides. Right? This shape will, oh mercy, this shape will tessellate the plane. How do we know? Because when we create a new one, everything slides in very nicely. Everything slides in very nicely. We can create tessellations using rotations. There are lots of ways to make these things, and all of them are worth playing with and experimenting with. So take paper and cut stuff out and then copy and draw, take a digital program, Paint would have been the cutting edge 1990s program, and jag a little edge there and whoosh, slide that over and see what you can do. This is a topic that is worth playing with, and I hope that you will before we gather. But I know I've gone beyond my 10 minutes, and I try not to do that too often, but there's no other screencast to do for this lesson, so I hope this is helpful.